So now we have another example, this time with a quartic function. So we're going to do the same thing that we did the other ones. We're going to find 0 with the calculator, and then we're going to use synthetic division, find our other zeros, use the calculator to find the turning points, then sketch our graph, and then identify the end behavior, the intervals, and the domain and range. So I'm going to start this on a new page. So our function was p of x equals x to the 4th minus 7x squared plus 12. So if we plug this into the calculator, we're going to get one of our zeros. So I'm going to use 2 as my 0. And that's from the calculator. So I'm going to use 2 with synthetic division. So we want to be careful with our placeholders. So we have x to the 4th. We don't have an x to the 3rd, so we're going to put in a 0. We have an x squared, so we're going to put in a -7. We don't have an x, so we'll put in a 0, and then our constant's 12. Okay, bring down the 1. 1 times 2 is 2. Add it, we get 2. Multiply it, we get 4. Add it, we get -3. Multiply it, -6. Add it, -6. Multiply -12. And no remainder. So we have, x cubed plus 2x squared minus 3x minus 6 equals 0. So we're going to group them and take out the GCF, which is x squared. We're left with x plus 2. Take out the GCF, which is a -3, and we're left with x plus 2. Smush it together, x squared minus 3, and then x plus 2 equals 0. If we solve this, we get plus or minus radical 3. And then if we solve this, we get plus or minus, no, just kidding. We solve it, we get -2. Okay, so now we have our 4 answers. We have 2 from the calculator, then we have -2, and then plus or minus radical 3. So let's start keeping track. So we have our y-intercept, a 0, and then our constant term. So our constant term was 12. Okay, the x-intercepts, we have the 2 from the calculator, so that's 2, 0. We have -2 from what we solved for, so -2, 0. And then we have plus or minus radical 3. So we have radical 3, 0, and then negative radical 3, 0. Okay, so when we go to put that on the graph, we can use decimals in the graph, but keep our answers as exact as possible using radicals for now. So now we need to find our turning points. So the turning points are the maxes and the mins. Okay, so you could plug in the original function and find your turning points. So if we do that, we get -1.87, -0.25. So that's one of the mins. The max is 0.12. And then the other min is going to be 1.87, -0.25. So you can see the two minimums are very similar. The x values are just opposites of each other. So if we go to graph this, we have so we're going to graph 0, 12, which is up here. We have 2, 0, -2, 0, and then the radical 3's are like 1.73 and -1.73. So about here and about here. And then our turning points, about here. So I'm going to label that one, -1.87, -0.25. I'm going to label this one 0, 12, even though that's my y-intercept. And then out here is +1.87, -0.25. So when we go to fill this one in, it's going to go down, up, here, here, So now we have our end behavior. So on this end, x is negative infinity, y is positive infinity. On this end, x is positive infinity and y is positive infinity. To do our increasing and decreasing intervals, we're looking at the x's of our turning points. So we're going to box them off. And the first thing that we do is we decrease. So it's decreasing from negative infinity to negative 1.87. Then it's increasing from negative 1.87 to 0. Then it decreases again from 0 to positive 1.87. Then it increases from positive 1.87 to infinity. So there's our intervals. Now the last thing we have to do is the domain and the range. So the domain, since it's even, the domain is all real numbers. If you look at the end behaviors, the x's are going from negative infinity to negative infinity. Or negative infinity, sorry, to positive infinity. Okay, the left end, x is negative infinity. The right end, x is positive infinity. So the x's are going to all be touched, so they're all real numbers. For the ranges will not be all real numbers because the end behaviors, the left end, y is positive infinity, and for the right end, y is also positive infinity. So it's not going to be all real numbers since one of those values is not negative infinity. So what we do is we look at our lowest minimum value, and since the range is equal to y, we look at the y values. Now the two minimums we have, they have the same y value. Okay, so in that case, you're just going to use that one. If one was lower, you would use the lowest one. So since negative 0.25 is our lowest, we're going to say that y is greater than or equal to negative 0.25. So it's just like when we did quadratics. Since it opens up, y is greater than or equal to. If it opened down, we would have y is less than or equal